close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left.
All right. Let's try this again. Hey, good evening, everyone. Morning, afternoon, wherever you're at. So, the couple people that were in the stream a few minutes ago, sorry for the inconvenience. I didn't have any sound. I can see that the sound's now being captured. There's an issue with my OBS, so if you could just put something in the chat, just let me know if you can hear me, and that way we can actually get started with the stream. But again, sorry about the lack of the audio issues first time around, but hopefully this time we'll get it right. So all right, so starting off with the content for tonight. So I was kind of struggling a little bit to figure out, the to-do list that we have. Let me pull it up real quick. Not that. So this is the to-do list that, I bring up practically every stream. Some things that we just need to check off. and it just keeps getting longer as I find more things to do or think of. So one of the things that I just thought of, it's always been on my mind, but I haven't added it to the to-do list until today, was incorporating a CI pipeline, or continuous integration pipeline. And what that is that it basically allows you to automate, your unit testing, your integration testing, your code formatting, additional linting. It helps automate all those processes. Anytime that, let's say, you make a merge into your main branch, or you push code to the main branch. So really it helps out a lot as the project matures. So I just kind of added it there. We'll get to that. That will be a stream in itself for sure. But as you can see here, there's a couple different things, and they're all scattered all over the place. Some are related to the back end, so the actual test jobs, the test script. Some are related to the web, the front end, so that would be HTML, CSS, JavaScript. And then you have some that are just related to the database, right? So we talked about adding the runtime of each job to the database record. So all of this in its own way can be prioritized, but for what my priorities with each of these objects are the yellow, I believe, is a priority 2. Let me just double check. Yeah. So we don't have any more priority 1. So last week, last Tuesday, we did a couple priority 1 tasks, which were adding test results to the database. So, they were kind of a priority 1 and pretty urgent, because that's without having the database results, then you really can't do anything with the tool. You can't interact with the API. You can't extract data. So we had to make sure at least we had some data in the database. So for tonight's stream, I'm going to focus on, I thought it would be neat that we could create a test script using pyATS, since, if you've been here from the beginning, I would say this is probably going on week 4, week 3 or week 4. I've talked a lot and extensively about pyATS. It's a huge library, a Python library for automation testing. So I figured it'd be easy to just create a test script from scratch. So basically, we have one now that will validate whenever a circuit's upgraded at a site. So most of it are routing and layer 3 checks. So I figured if we can basically take the scaffolding of that circuit upgrade test script and create a layer 2 test script. And just some things, I noted some things in the description here. And I'm not sure if if it's small on stream, but I'll kind of just read it off. So just some things I had. So tests should include switch hardware basics, so your CPU, memory, power. The input errors are, the interface input errors are below a certain threshold. I think I just put 100 for the example. A default gateway set and spanning tree is configured. Some other things I thought of are VTP, which is your VLAN trunking protocol, is disabled. So for those that don't know, VTP, in the networking world, it basically allows you to, some say it's kind of the poor man's, the first choice or the first implementation for automation, because it allowed switches to basically automatically configure VLANs, right? So it was a kind of a server client architecture, and the server switch, or what they described as the server, could basically, if you added a VLAN to the server, the VTP server, then it would push that VLAN to all of its clients. So as you can imagine, that sounds great, because then it's like, all right, I don't have to touch the other switches. But as you can imagine, if you did the opposite, like remove the VLAN, that could take down your entire network and propagate that issue. So not many shops use VTP anymore, just because there's really no need to. Like there's not there. It was I can understand a theoretical idea, but at the end of the day, you can easily use an automation tool like Ansible, Python, anything Pythonic. There are plenty of other automation tools these days that you can use without relying on VTP. So yeah, we'll make sure that it's disabled, and I think that's probably a good spot. I just realized. So we'll actually be testing. Hopefully, we'll get to the point where we can test this test script, and it is in a virtualized environment, so we won't be able to test power because it doesn't have physical power supplies. So I just back that out, but everything else should be good. So, all right. I guess let's start with the environment. So I brought this up. I'm trying to think. The last time I showed you the EVE-NG environment. So I have a couple different virtualized environments, virtualized network environments. I have one that is in Google Cloud, which I showed you a few streams ago, and that's how we've ran our test scripts in the past to generate data and interact with the NetCheck tool. But recently, I bought a used Dell server and basically have a local EVE-NG cluster or EVE-NG server, at my house. So luckily, the nice part is everything is local to my PC, so I don't have to be VPN'd into my Google Cloud VPC. So, it's nice in that way, and also I can boot it up, turn it off, and I don't have to worry about, storage, networking, all those little charges that add up over time. So I'd still have the Google Cloud instance. I'm going to be testing with the local server tonight, and most likely for future streams as well. So this is basically, I just created this topology really right before stream. So there might be chances that we'll be configuring some of these devices on the go, but you'll see here, this switch here, I just called the stream switch. This is the one that we'll be running tests against. Since the focus of the stream will be on creating the test script, I don't want to spend too much time with the actual CLI. So I did prep it, and I have it up here in one of my terminals. There we go. So have it up, and hopefully, I always like just increasing the font in PuTTY. So hopefully it's big enough for the stream as well. Oops. Hold on. All right. So let me just show you. So you'll see, just doing a show interface status, they all show as connected, right? So that's like one downfall, I guess you could say, of virtualized environments. Depending on what emulation tool you use, I'm using a virtual iOS image from Cisco, and just to show you real quick. So it's the virtual iOS layer 2 image. So I think it's running 15.2 or 15. I think it's 15.2. Yeah, 15.2. So yeah, it's running just vanilla iOS 15 versus like a newer Cisco device you'd find is like iOS XE. So let me just show you, kind of have it segmented off here. So that's my home router. I have kind of just a static route in there. I kind of converted I'm running a layer 2 image, but I converted the gig 00 interface to layer 3 just so that way I have an IP I can hit. As we dig deeper into future test cases and test scripts, there will be a chance I most likely will be using more devices in a topology like this. I just built out this topology really. One, I will be configuring it at some point, but two, just to kind of show how you would set up a topology in EvenG, or just like a quick example of that, right? So you know, router, and then here's your 4 switches. So here it'd be pretty neat to attach like a virtual PC on the edge of this switch and to see what route it takes, what links, because there's now 2 paths, to this router. So that's more like going down the network engineering path, and but you can use EvenG for that as well. All right, so yeah, so I could ping the gateway, and actually I was already SSH to it as well. Yeah. So you can see I'm SSH from my home PC. I'll do the same command, show in status. So I actually might just use, well, this one's kind of tougher to read. I'm kind of looking at the preview of the stream. But anyways, that kind of just proves I can access it from my computer, which means that the NetCheck application can also access it. So I'm pulling up the code here. So we're going to do a few things. We have to, for this pyATS job, we're using Easypy. So I mentioned this in the first stream. There's kind of 2 different ways to execute test scripts. One is through the standalone execution, which prints basically, there's no archiving, there's no zip folders to look through for results or logs. Everything is just printed out to the standard output, which in our case is it's just the terminal. So let me just see here. So we have to create another test script, right? And we'll go through this. There's a good chance that we only will be, hopefully we'll be able to get to creating the test script, adding the tests to the front end, or creating a front end form, and then actually logging into the device and running the checks. That's the ultimate goal for this stream. But there's a chance that we only get through the actual test script, because I do want to take some time and actually talk through each section and why each section exists. So yeah, so we'll go with that, the test script, and since we're using the Easypy execution, and I'm sorry, I did not explain the Easypy execution. So the standalone is, I already talked about, really no archiving. It's just for testing purposes. The Easypy execution, you create a test script just like you would with the standalone execution. So, you run through your individual tests, and I'll explain what all this means, but you can see, test, another test, another test. And then you use what's called a job file to run your tests. It's pretty simple here, but the nice thing is you can run multiple test scripts from one job file. So in our case, we're not going to be doing that, but you could. So for example, if we wanted to test like a circuit upgrade, and then let's say we also wanted to test like external connectivity to the rest of our network. So let's say pinging some core routers, pinging a couple important branch sites, you could do that in a separate test script and then just run that test, do another, use the run method within Easypy, and then just run another test script. And all of the results will be put into one archived zip folder. So pretty neat. So anyways, we'll be creating another job file. So we have to create the test script, and we have to create a job file. And then let me think what else we have to do. If we get to that point, then we get to actually creating, let me pull up main. Then we get to actually creating the front end. And the front end will be interesting because, if let me just pull it up real quick. Unicorn main. right, so it's up now. So the front end's neat because we already have a validation tab, and I plan to add all the necessary fields and information into this card, or what this Bootstrap theme calls a card. So you'll see like circuit upgrade I made into a card, and then this switch, I don't know what to call it, whether it's like a layer 2 switch check, or like, because the whole point of netcheck is to check against common use cases or common changes. So like a circuit upgrade, something common. I guess a switch install, I guess we can call it, you know, installing a new switch, and then we can kind of tweak it as we go. Because like I said, I definitely see this tool evolving into, you know, right now it says it has static thresholds, right? It says below 75% for CPU and memory utilization, a minimum of 2 established eBGP neighbors. I mean, I foresee this tool having like a form right here, or like an input to say, all right, how many eBGP neighbors are you expecting? Do you want this threshold to be like 50%? Or would you want it to be closer to 90%? So I definitely see these values changing. But for now, these will all be static values. So we'll get to the front end after we create the test script, because worst case scenario, we'll create the front end on the next stream. But for now, I want to go through the technical nitty gritty of creating the actual test script and the job file. So let's get started by doing what makes the most sense. Copy and paste. Right? And we'll just rename this switch. Should we call it switch upgrade or switch install? Maybe I'll just stick with upgrade. No, upgrade, I don't like that. We'll just do switch install, because upgrade makes it seem like, I mean, there's multiple ways to upgrade a switch. You can add a switch to a stack. You can completely refresh it. So yeah, we'll just do switch install. So a couple things here. Let's see. All right, so I'm not going to harp on it too much because I do want to get the test script finished in this stream. But we have really 3 main parts. You have your common setup. You have your actual test script or test case section, which has all the individual tests that we'll run. And then towards the bottom here, you have your common cleanup. So your common cleanup and your common setup are required. And basically what they do is the common setup sets the stage for your testing. So let's say for your device, to configure something, you have to remove a feature and then re-add it in after testing. So in the common setup, that's where you would remove the feature that you're testing against, and then in the common cleanup, you would re-add that feature and maybe do some validation. So that's where that's coming from. The test case section, pretty straightforward. It's your actual test case. So in our case, we're actually going to call this switch install. Oh, and just so this doesn't keep rebooting itself, I'm just going to go ahead and close it. So kind of cancel that out. All right. So we're kind of doing the same thing for this. We're still connecting to one device. That one device is going to have an alias. I went over test beds in a couple streams ago, where you have your name, your platform type, OS, and then you could optionally give your device an alias. Well, in our case, we have an alias that's kind of common throughout, and it's going to be called UUT, or unit under testing. So in that, you could find in the let me pull it up here, in the validation, in the helper. So you'll see we're generating a test bed, and all these values are grabbed from the front end form. And so you'll see that the username, password are grabbed from environmental variables. The device IP, host name, and operating system type are all grabbed from the form. And then the alias here is statically set to UUT. And like I said, this works, and I most likely will be changing this method to be like generate single device testbed. But once we add more devices, we can't obviously use the same alias across multiple devices, or things will break. So, but in this case, UUT will work. That just means, all right, load in our testbed file, and let me actually get rid of some of these. Load in the testbed file, and the testbed's gonna be this block of code right here, which you can see has only one device, and the colorized brackets actually help. It might be tough to see on stream, but basically there's a purple line right here. So these are all the devices, and you can see there's only one device here. So, but it's easier instead of trying to just grab the host name, because that's dynamic, and just giving it a static alias will help. All right, so this is somewhat repetitive here. I actually probably could slim this down to just one line of code, but we assign a device variable, and we assign it to the device object that's pulled from the testbed that has the alias UUT, right? Obviously, like I just mentioned, we only have one device in the testbed. And then what we do is we add the device as a parameter to the test script. And what this allows us to do is use it anywhere in the script. And when I say script, I'm talking about the entire file. This is the switch underscore install.py is a pyATS test script. So I guess I should, so a test script is the entire file. These are test sections, common setup, the switch install, and then common cleanup at the bottom. And then individual tests or test cases. I'm sorry, this is the test case, which is a section. Test case is a section. Switch install is the name of the test case. Hopefully that doesn't make it more confusing. And then each of these with the decorator AE test.test are the actual individual tests that will run. So the test script basically will now have a parameter called device. And what's the device equal? It equals this device variable, which is the testbed device. So now, anytime you see device, we're referring to that one device in our testbed. So you'll see right here on line 16, we have a step that just connects to the device. And all we do is this is a dynamic value, so we're not gonna, that's why you see it in the F string format, because instead of saying connect to device, we're actually gonna say connect to and then the device name that's provided from the form. So hopefully that makes sense. And then within that step, all we do is device.connect. And that's just a common, if you read through the documentation, that's one of the most basic examples, right? You define a device in a testbed, and then you connect to that device. So that's all that we're doing in our common setup. But maybe there's some other things that we might do with just the switch install, and that's where you kind of can customize it. All right, moving on to the actual test case. So we have the switch install is the name of the test case, and we have our individual steps within, and I'm sorry, I shouldn't call them steps because there are steps, the actual name of steps, and you'll see that right here. We have our individual sections, right, our subsections of this test case. And so we have an individual setup. So these are all optional, right? But we optionally I have a setup section here, and all it does is make sure that the device is in a connected state. If so, all right, that test passed. Else it completely fails and says it can't connect to the device, right? Because we connected to the device in the common setup section. All right, so that one's pretty simple. And we mark it with the .setup decorator instead of .test because technically that's part of the setup process. And we could use the setup decorator to do some additional things. So let's say, going back to the example of like we disable a feature, right, in the common setup section, just because we need that feature disabled so we can do some additional testing without the feature. But let's say one of our test cases needs that feature for just its testing, then we would probably put that in the setup section because for that particular test case, and then we would go through our tests. So just think of it as like a, the common setup is your global setup, how you're going to test the infrastructure. And then in your test case section, you could have a separate setup section that would be particular for that test case. So hopefully that makes sense. But in our case, I'm using it literally just to check to make sure the device is in a connected state. That's kind of like just an additional check here. Let's see. All right, so we're verifying some of the basics of the switch. So funny enough, that was probably a typo on my part. So we're testing and making sure that, but it works for this test case. So we're checking CPU utilization, and we're doing, remember, we just copy and pasted the circuit upgrade script. So we're doing that same test, but within this switch install test script. So this is where, personally, pyATS is a very big library, very heavy, compared to other network automation libraries like Scrapply or Nornir, because those are very easy to get up and running. This pyATS is definitely heavier than them, but to me, like some of these, like what I'm about to go through, really help. Like the readability is just on another level for me, and it's complete personal preference. Nothing against those libraries, because those libraries follow kind of the same suit, where you create an inventory file and it's a Python dictionary. So, but for me, like I'm just gonna take this section here, right? Because all in all, whenever I created the circuit upgrade script, it was, most of these steps were just copy and paste and then substituting out some of the fact gathering. So whether it was using the device, the API, or using parsers. So, but let's just take what I highlighted here in blue. So we're using what's called a step. So basically what steps do it's just a smaller piece to a test, right? So you could either do a test and just say, all right, I'm going to perform one test, pass or fail. What steps do is say, okay, well, let's say I want to do 3 steps within one test. If one of those steps fail, then the test fails. Okay. So I hopefully, that's kind of at its simplest form what steps allow you to do. So the way I organized this test was to say, okay, well, I want to test all the basics of a device, right? So your CPU, memory, let me see what else. Just CPU and memory. Perfect. So instead of writing a test to say verify CPU and then another test to say verify memory, we can just do all that in one test and then use steps to break that down further. So, all right, so we start and then we put just a title basically to the step. We say, all right, we're going to check CPU utilization. So I use a try and accept block. The nice part is what it will do is it will run all this code. Obviously, if there's an exception or an error, then the entire test will fail. Actually, the entire test script will fail. And you'll notice that because I'm using self.failed. Whereas in here, in the try block, I'm using step.passed and step.failed. So that's a key difference, because if, let's say, we connect and CPU utilization is over 75%, then this step right here will fail for CPU utilization, but it will move on to the next step. And actually based on where I'm seeing now, it won't move on because there's an additional parameter you have to add to allow it to move on. Anyways, I'm not gonna divert too much, but yeah, there is a additional parameter I would have to add. So if this step failed, then this test would fail. But let's just say we had that additional parameter, then the step it would move on to the next step because it has just step.failed. But if self.failed, because remember we're an entire at the end of the day it's still a Python class and it's referring to itself. If it fails, then the whole test case of switch install fails. So, all right, so let's quickly just go over this. If device.os equals iOSXE or iOS. So what that tells me is to say, okay, essentially if it's a enterprise Cisco switch, because most switches nowadays run iOSXE, but since we're running a switch in the virtualized environment, it's running 15.2, as you saw in the beginning of the stream, then it's running iOS. But I did this because this API exists for both platforms. So I think I mentioned this before. The Genie library has a list of data models, parsers, and then what they call device APIs. And so just for completion's sake, let's go to Genie APIs. And we'll just take a look at this API. And honestly, this is kind of for me as well. Don't need the blog post. There we go, Genie docs. Available APIs. So what these APIs do is it basically it's at the end of the day, it's still parsing, but it's a little more, it may use multiple parsers to gather the data. Well, maybe. Hold on. Available parsers. pyATS. Just taking a bit. I believe they may have also pushed their monthly release today too, so figures I'm streaming on the day that they're pushing that. And I don't know timing around that either. So, okay. I think we'll be good. It's definitely running slow. All right, so you see here on the left side, we have APIs, the clean utility, and we're not going to be diving into that too much, but we have also models, parsers, triggers, verification. So we're actually going to be looking at the APIs, and we're going to be obviously focused just on, actually just to show you that they're the same, let me just grab the name, get platform CPU load. Right, so you kind of have the same API for both, for a bunch of XR, NX, so your Nexus, iOS XR, iOS XE, and iOS, right? So, and you see get platform CPU load, get platform CPU load. So we'll take a look at this one, and if you click on just the API, it will actually show you documentation for the different operating systems as well, just so you can compare the schema. Or I'm sorry, the arguments and then what's returned. Normally, if this was parsers, you would see the schema. But so you can see iOS, iOS XE, pretty much they have the same arguments and the same return. So it returns a CPU load, which is an integer. So it returns an integer value. And by default, it returns the 5-second average. Most of the time that should work, but let's say you wanted like the 5-minute average, you can easily change that using rates. Where is that? Right here, check key, and then key in parse output. So you can see it checks 5_sec_CPU. So the way you would change that is you would go to the parser for get platform CPU, and I have to check the exact command, but I want to say that's what it is. And you would change, you say check key equals, and then maybe it would say like 5 underscore min underscore CPU for like a 5-minute interval. But 5 seconds is fine. Honestly, we're just, using it for testing purposes right now. And then if it needs change in the future, we know how to do that. So, accidentally ran the script. All right, so we got the CPU load. Like I mentioned, it returns an integer. So, and that integer will be captured in the CPU util variable. So all we do, since it's an integer, we can do an easy comparison. We can just say if it's less than 75, then it passed, right? Else it failed. And then you have your exception to say, okay, well, if this doesn't work, let's say for whatever reason we say get platform CPU load, and like for whatever reason there's a bug in this API for this specific pyATS release, and it fails completely and parsing doesn't work out and an exception is thrown, then we'll get self.failed. The whole test will fail, and then it will say could not parse the data, and then it should print out the exception. So that's like, I'm kind of glad that we had kind of some boilerplate code there to go over, because that's kind of the power with pyATS. Is this is what it's really meant for, is to run tests. And obviously I'm just running show commands here, but you honestly could say if CPU utilization is less than 75 or greater than 75, let's say like in this step, instead of just saying, hey, it's failed, running over 75% CPU utilization, you could actually parse out, I'm sure there's a way to parse out the actual process that's taking up the most. You could find the name of that process and then maybe use it in another command to kill off that process. You know what I mean? So that's like the nice part about using all these different parsing tools, because you can get the values you're looking for dynamically and then perform an action on them. And then at the very end of, like, let's say you kill off that process, you could rerun this test. There are ways that you can, what are called loops. You can run a loop on this test to say, all right, well, let's check that again. Oh, it's under 75? All right, print me out a list of those processes, just for keepsake, right? So hopefully that was a good example that you guys could connect to, because for me that's what it's all about. So all right, same thing with the memory. I'm not going to go over memory because it's the same thing. We're just using get platform memory usage. It returns an integer as well, and we just do a quick comparison, make sure it's below 75% memory utilization, and if so, it passes that test. It passes that step, which that's the last step for this test called switch basics, so the test would pass. So hopefully that makes sense. We have another test for verifying the iOS version. I don't know if I included it in my description here. No, I didn't. But this would be a perfect thing to test. Check iOS version. And the reason it would be really good to test, or like include in the test script, is because a lot of switches, as some of you may know, like they come out of the box with a specific iOS version. And if that version isn't what your corporate standard is, or your team standard, then it's going to throw everything off. So what we'll do here is just check for the iOS version. Now, you could kind of take this a step further and kick off another process and say, okay, well, let's after we check it, if it doesn't comply, then what we'll do is kick off a process to upgrade the switch. Now, that would be a little more than testing, because that's remediation as well. But you kind of get my point, is you can take it to that next level if you wanted to. In our case, obviously, because I'm not upgrading in these virtual iOS images, then I'm just keeping it as is. it'll just say the test will just fail, and then it'll report that it failed. So, all right. So we'll verify iOS version, iOS XE standard. So, iOS XE and iOS standard have two different numbering, I guess you can say numbering schemas, but iOS XE really started, it had a weird time where it was in like the 3 range, so like 3.06.01, but most recently it's been on the 16.xx train or 17.xx train, which makes sense because iOS XE is newer. So the standard iOS went from 12, so 12.x to 15.x, and then iOS XE kind of took over, which went to 16 and now 17. So the reason that's why you see two different variables, because you obviously would have different standards depending on the iOS version. So actually in our case, because our switch is running 15.2, I'm just going to change that standard to 15.2. You'll also see if, depending on the OS version, we're going to be extracting different keys from the parser. So here we're grabbing the XE version, but if it's just an iOS device, we'll grab just the version command, or the value for the key, for the version key. And so this is kind of a lot to break down, and I'll just kind of go over it at a high level. So the DQ module, I've mentioned it many times before. It comes with the Genie library. It is awesome. It stands for dictionary query, and basically what this allows you to do is, instead of, if you were to query, or I guess try to dig through a nested dictionary, it would be a bunch of for loops, right? So you would just do like for version and the software image. You would then just dig deeper and deeper until you found the key you're looking for. What DQ allows us to do, it has available methods to where you can say, actually, out of this dictionary, I only want this specific path, or these specific values at this level. So what I'm doing is saying, okay, we'll take that self.version, which is the show version command parsed, and find the iOS standard that we've declared up here, or in the iOS XE standard. If it contains this number, this string somewhere in the path, let's narrow it down to that path, and then within that path, just get the values for this specific key. So like I said, vanilla iOS is just the version key, and then for iOS XE it's the XE underscore version. And just to visualize it for you, we're going to just do a show version. Perfect. And we'll do ASA iOS. All right. So you'll see for iOS, you see how long is, so each of these are nested dictionaries, right? In here. And so that's why, like, if you try digging through all of this to find one specific value, it would be a nightmare. So what I did was I said, okay, well, let's look for example, iOS XE. I said, well, let's look for that, the standard string, whatever that is. In our case, it's XE underscore version. So technically it'd be easy just to do version and then XE underscore version. But I think I was just testing myself with the DQ module to see what would, what I would get, basically. What would the results be? But you can see, like, I can get a bunch of information. When the system was restarted at, the uptime of the processor, the control plane, I believe. The CP's for control plane. But the processor. The last reload type, so it could tell you when it was last reloaded and why. Like, was it powered off, powered on, a reboot command, whatever. But there's a bunch of different, information you can get in here. But for our case, we just want the version and and just the iOS version. So like I said, this is probably overkill. Now that I've just revisited the parser, this is definitely overkill. But it's good practice. But all right, so the get values returns a list of values that is found. So if it finds a version and remember, since we're looking up the specific standard, we don't have to do any sort of equal signs. We don't have to say if the standard version equals the iOS version found on the device. We don't have to do that because we're already saying, all right, we have to make sure that the path contains the standard, and then we get the value. So at the end of the day, the get values method returns a list. And so all this if statement does is say, well, if the list is populated, then it passed, right? Now you could say if the list index 0 equals the iOS standard, then it would pass. But I decided to just trust on the parsing and say, well, if we already found a part of the dictionary that equals the standard, the iOS standard, and then we get the value of version and it returns a value, then I would say, we're probably good to go. So there's that. All right. And let me just check the others. So that's all the steps for verifying the iOS. External pings. Now this remember was for the circuit upgrade. We don't really need that. And then gathering logs. So we'll keep this. It's always good to gather logs. I don't know why it says checking iOS version. So what I'll say is gather only error logs. And this kind of goes back to your CCNA days of remembering the different severity levels. So in here you'll see, if we'll go through the logs and we'll say, well, if the logs contain a level of error, then we'll get all the messages logged as error. Right? And if there aren't any error logs, then we'll say, oh, there are no error logs, step passed. But if there are error logs, we'll say that step failed. This is kind of like one of those things where, okay, is the error log legitimate? Is it a cosmetic bug or is it an actual issue? So not too worried about that. So the only one that we need to change is this external pings. And let me see. Go back to to-do list. And CPU, memory, input errors, default gateway set, VTP is disabled, STP is configured. Okay, so let's do this. Let me write down the different tests that we need to run. Tests to include, I know you can't really read it. I'm just writing them down. Input errors are less than, we'll say 1,000. Because input errors they're not exactly a good thing to have, but it's okay to have. If you have some, like a couple, that's somewhat normal, especially if you're plugging in a new circuit or something. But anyways, we'll just do less than 1,000 because it's not good if they're incrementing. That's definitely not good. Let's make sure a default gateway is set. And let me see. STP is configured. So this was a little tricky. STP is your spanning tree protocol. Because we don't know the entire topology, because our test bed's only one device, you could build out your entire topology in a test bed, and that way you can test against your entire topology to make sure spanning tree is right. The ports that are forwarding, the root ports, the ones that are blocking, like that's all good. just for brevity purposes and just getting kind of everything up and running, I'm just going to check to make sure it's configured and running rapid per VLAN spanning tree. So that's a particular type of spanning tree for those that don't know. And then we're going to make sure VTP is disabled. All right. So let me do a quick time check. So we have about, since the stream messed up, I'm going to go a little longer. So let's give ourselves like maybe a half hour. In the half hour, I want to build out. So what I'm going to do is build out, let's do just one of these test scripts, maybe two, or test cases. And we'll build it out. And then what we'll do is work on getting the front end and kind of putting that together. Because ideally, I'd like to get to a point where like we at least get like I don't want to call it a dry run, but we can like run the actual test against the device. Pass or fail is ran against the device. That's kind of where I want to get to. So, all right. So let's get to. So let's start like this. So we don't need external pings because I'm not too worried. Since we're doing, this is for a switch install, we're not going to do external pings. So let's just say interface errors. Let's call this test interface errors. And all we're doing is checking for input errors. All right. So, and because we're only doing one test, we don't really need a step in this case, but just to keep everything the same, I'm just going to keep the one step. It won't hurt anything. All right. So this is where it kind of gets fun. So we need to check for input errors on all interfaces. Watch, I'll end up picking the toughest one. All right, so the device, so yeah, we have our try except block, and then if device OS equals iOS XE or iOS. This works if the API or the parser returns the same output or is the same, right? So what we're gonna do is, also I have no idea why that's configured the way it is. Let's just check our parser, our available parsers, right? So, or let's check our APIs. So the APIs, like I mentioned, can help us with some of these use cases. So let's just look up errors. Unlucky there. Verify interface errors. Now, the only thing that sucks about this is it's only available, as you can see, with iOS XE devices. There's a chance that, let me just click on view source. Since all these parsers are open source, you can actually go in here and see what command they run. Okay, so they run the show interface command to get for this API. But so let's do this. Let me actually just go to parsers. So realistically, I would use that API, but show interfaces. This is gonna be a lot of output. Yeah, like this is a ton of output. Oh well. Oh, that's for COMware. iOS. I think this is even more output. So I want to say these look to be the same. Let me see if within the code, the source code, parser for show interfaces. That's just an exclude list. Does this work for? These are iOS parsers. All right, let's see. Let's see if this iOS XE uses the same. Okay, so it looks like it's a little different. It may not be, but just to be safe, we'll just do... it's fine. We'll just test the waters. We'll just do parse. So what we'll do is now we'll just say, okay, let's assume that the structures are about the same. And the importance of that is the structures being the same is when we do the parsing for the value we're looking for within that dictionary, or in that parsed output, that we can kind of query the dictionary at the same, with the same, we can use the same key values. That's what I was looking for. Jeez. And so let's just do, all right, what was the name of the parser? Show interfaces. So all we're doing is saying, okay, well, let's take the device, and we're doing show interfaces, and we're going to say interfaces. So I actually like to do, create, I'm using self.interfaces here because if I'm using it in different tests, I like assigning it to self, which basically keeps it within the class. And remember, the class is a test case itself. So let's say I want to use the interfaces output somewhere else in the class. In this case, we're not, but realistically, this captures all the output for the interfaces that we're looking for. Your operating status, whether it's connected, enabled, error disabled, like it returns all of that for every single interface. In our case, as you can, well, you can't tell, but this is the test device we're running against. We only have, like a normal switch would have, 24, 48 ports. This, if you run show interfaces, oh, that was probably silly. Yeah, let's just do this to show you there's only 8 interfaces, right? So it will still be a lot of output, and you can see here a bunch of text, but at the end of the day, it's not 48 interfaces. So we're going to say self.interfaces equals, we're going to parse this value, and what's going to be returned is all this for every single interface. But what we're looking for is input Q drops. We kind of kept it really open because we said errors, input errors, in rate, in error. Here's input errors, CRC errors. That's like a common example that the pyATS, the documentation, uses. So I really don't want to use that. But let's use in errors. So we should be able just to grab that value. Because the thing is, let me just try to I'm grabbing all of this out, the schema here. Real quick. So let's see. Nope. Text file. Boom. And the key we're looking for is in errors. Yeah, so we're only, luckily, this is only the only name. Sometimes you'll run into where the same key name is within the same, in the schema. So it kind of like, it sucks. But in this case, I should just be able to say, all right, well, I could dig through this and say, all right, it looks like it's in the counters dictionary, you can see here the counters dictionary ends here. So we could say, all right, yeah, get into the counters dictionary for this specific interface. But that's not what I'm here for. What this will do is, if we do the DQ, if we use that dictionary query library I was talking about, and use the get values method for in errors, what it will do is return a list of those values for everywhere it is contained within the output. So in our case, because this output all is for, like, it says any here, so picture like interface 1, interface 2, and each interface has all this output. So what we could do is get only the in errors value for every interface. So the list should be about eight items in length, and then what we'll do is just loop over the list and say, well, if a particular value equals is greater than 1,000, then let's flag it. And there's probably a better way of doing that too, because what we could do is say, well, if it equals, we could create a list of like the interface name with the associated in errors, and then we can say, well, give us the interface that has the errors. But in our case, let's just say if there's any interface with more than 1,000, we'll just say, hey, it failed, and we have to get back and kind of check through the interfaces. All right, let's see. And if there's any questions, as I'm going through this, I know kind of talking over a high level. If there's any questions, just let me know. All right, so self.interfaces. So let's say we're looking for input errors. And what we're going to do is say, all right, DQ self.interfaces .get values, and it was in. So you have to make sure this is right, in errors. You have to make sure the key name is right. And I just had it up. Which file was that? In underscore errors. Yep. All right. So what this will do, and I'll just kind of make notes as I go. Returns a list of all input errors. Of input errors for all interfaces. Yeah. Oh, and you just saw that kind of just auto format. It's because whenever I save a file, it automatically formats to the black code formatter. That's what the code formatter name is. It's just called black. So that's why it did that. All right, so input underscore errors, that's a list. So what we'll do is just say, we'll just keep it simple. We'll say for errors in input errors, right? Because that just loops over. Oh wait, I don't like using a plural. If error is greater than 1,000. Actually, let's keep with doing the pass value first. So we'll say if it's less than 1,000, then we'll say passed, and we'll say else. Right? And just to explain this a little more, so what we're doing is looping through a list, a return list. And normally I would go through and actually like parse out the output, and maybe I'll do this in the next stream. It will return a list of all of the actual in errors, the value for in errors, which is a integer, and you can see that here. Remember, I just copied this from the documentation. So you'll see, class int, and so that way I can actually do a comparison. If this was a string, then I couldn't do an actual comparison unless I convert it to an integer. So just kind of a heads up with that. So we'll say for every error in the input errors, if it's less than 1,000, meaning that the input error is less than 1,000, the number of errors, then we're going to say that the step passed. Actually, hold on. That wouldn't work. I hate using this, but what we'll do is say pass. And then, let's see. Oops. Okay. You're probably like, what just happened? So what I was doing before was saying because remember this list is 8 items long. If let's say item 1, that the number of input errors was 500, then it would just pass, the step would pass automatically. It wouldn't check the other 7. So what I did here was say, okay, well, if the error is less than 1,000, then, well, that wouldn't even work either. Well, no, it may, because the pass would work, and this is why I don't like using pass, because it doesn't really provide any value. All it does is to say, okay, well, it basically moves on to the next block of code, but the thing is it's stuck in a for loop, so it will still run. We'll keep that as is. I really don't like doing that. Probably better, like something better would be to I'll stick with pass, right? Just for sake of time. But something better would be like a print statement, like a logging, something to log. Anyways, if it's less than 1,000, just pass it through, which means, all right, skip the else statement. It means we're good. But if it's greater than 1,000, number of input errors is greater than 1,000, then the whole step fails. And we'll say one of the interfaces has more than 1,000 input errors. Right? So yeah, that makes more sense. So that way it iterates through every one, and then if it finds, let's say it's item 1 or item 7, if one of them have greater than 1,000 input errors, then the whole step fails, meaning because in this test there's only one step, that this test would fail. And so yeah, so that would fail. Otherwise, and this is kind of where it gets a little tricky, after it exits the for loop, if it survives the for loop, right? Let's say everything passes, then the step will pass, and it will say the pass message will be all interfaces are clean of errors, of input errors. All right. So we're good. So passed, and then obviously, like I said, the except block is literally used for if anything crazy happens or something goes haywire in the try block here, we'll catch the exception, and then we'll just print it and say, it fails, and then yeah, we capture and print out the exception. So all right, that's done. So I'll get rid of that. We'll keep it there. Actually, I'll keep that so that just as a reminder. And then what I'll do is we'll just put a to do here. Actually, we'll say these are done, and then to do. So Got the input errors one done. And we still have these ones will be pretty simple. It's just, I want to put a focus back on the front end. And actually, before we even do the front end, let me set up the job file, and then we'll see what we can do with the front end in the remaining time we have, about 15-20 minutes. Go ahead, copy. So all I'm doing now is just doing a copy and paste of the circuit job file, and we're just going to switch and install. So pretty simple. Same concept here. Can get rid of that to do. Need that. So we have our test script, and as I mentioned in the beginning of the stream, the test script has to be ran somehow. So it uses what's called a job file to run and run individual jobs. In our case, we're only running one job. And so here, like, it's statically set to circuit underscore upgrade. I'm going to change this to switch underscore install. And all this does is say, okay, well, go to my test scripts folder here. And remember, this is all ran from the perspective of main.py. So under main.py, you'll see where it's at. It would go to test scripts and then the name of the test script. Pass in the runtime parameters and then the test bed. And in this case, we're literally just going to use the same process that we talked about before, a temporary test bed, and then gathering the results for that. So, all right. So the job file is practically done. We'll see if it throws up some errors, but yeah. Pointed to the new thing, the new test script. All right, this is where the fun begins. This will be easy because I can just copy and paste most of this. So let's do some. I don't think we've actually messed with HTML on stream before, but let's just take a quick look at that. Let's take a look at some of the templates. Right. So just for everyone's, the way we'll actually gather the information, because remember with the test script, let me just get rid of the job file. The test script, what we're looking for is we still need to generate a test bed to run the test script, and get a validation. And we have to use these helper methods that we talked about before, and generate test beds one of them. So items that we have to capture from the form are the host name, device IP, and the OS type. And the OS type's a drop down, so it's not like the user can just input whatever. But let me pull up the actual form real quick. We don't need any more Genie. So we're on the validation HTML, and you'll see, circuit upgrade. We're going to keep this kind of card format because, and I'm kind of excited about this part. I have to figure it out, but it's kind of exciting to think that it's possible. Is we can run multiple. I would like to, have all these jobs in like these individual cards, and you could run multiple jobs at once, and then have like a results tab that keeps a track of all the different results, and you could download them and view them separately. So think of it like as a queue. So that's kind of the end result, which is why we're kind of putting everything on one page versus having multiple pages for each different use case. All right, so now that you know what we're changing, we're actually changing this card right here with TBD. So we'll be copying a lot of this code for circuit upgrade. So let's go to validation, or this one, validation.html. So what we'll do is my plan, what I'll do is just literally copy and paste the circuit. And it should show up as like the same. Yeah. Let's see. Boom. Cool. So they look the same now. Nice part is because we just copy and pasted, they'll look the same, have the same widths. But now the easy part is just to swap around some text. So the header, instead of being circuit upgrade, will be switch install. This is super important, especially if you're new to HTML or just creating forms overall, web forms. So the form ID is actually what's used when you click submit. That's actually used in the routing for the backend. So you'll notice in main.py, there's a app.post / validate form that's put over this method, and that's where all all the meat of the processes happen, where the actual job results are ran, the test beds are generated, and all that. So that's where it's super important. Remember, I copied this from circuit upgrade, so I'm not going to. I don't really want to use the same method because one, that's going to make things very confusing, and two, there's different things that might change with this method specifically for circuit upgrades. So I'm actually going to create a new method under main.py, and we'll call it validate switch install. Validate switch install. Okay. All right. So what's checked? Device basics. So this is kind of just a quick run through just to help the user out. So we check the device basics. We check verify iOS version. We don't check the BGP neighbor because, well, it's a layer 2 switch. So ensure switch is running proper iOS version, and we'll say image. Let's see what else. Interface errors and gather logs. So we'll call this one interface errors. Verify interface errors. Confirm there are not input errors on any switch port interface. Probably a little verbose, but it's better to be verbose than not have enough detail. All right, so what we'll do here is call it the switch host name. I just switch around the ID and the names here, because that way if you reference them in the, like I said, in the back end, you reference the different names. It's just easier to have them differentiated, especially if you have multiple forms. Now, like I said, this could get changed for sure, but just to keep it simple, and like I said, after stream I'm going to upload all these changes to GitHub so that way you can view them as well. Switch OS type, switch OS type. we'll take out ASA because that's not a valid switch type. Switch IP. Switch OS. So you might be wondering, like, this seems like a lot of work for creating a new form. Like I said, I'm definitely not a front-end guru. I'd like to learn about it, but I'm definitely not I'm not exactly the best. All right, so this is where it kind of gets interesting. So I changed around all the IDs and the names to match or be just different. Like I said, there may be a better practice. This is kind of just how I've done it. So the last piece here is a little piece of JavaScript, which ideally you would put in a separate file. And since we're reusing it, we're reusing the same snippet of code, we probably should, but just for simplicity, we'll just kind of keep it separate. So all it does is say, okay, well, when you click the submit button, then disable it so that the user can't keep clicking it. That's one. And two, add a little spinner, right? So I've, in past streams, whenever we've done testing, you've seen I click submit, it disables it, the button, and then a little spinner shows to say, hey, it's loading, it's doing something. What did we call this form? Validate switch install. So you'll see here that it'll say, let me just fill this out real quick, sorry. All right, so you'll see that, okay, when document.ready basically means once in HTML, the whole web page is considered a document, HTML document. And so once that's completely loaded, then it will load this little bit of JavaScript. And so all this is saying is when this button is clicked, right, and that's a submit button, then we're going to validate switch install, basically submit the form, because this is the name of the form. Along with that, we're going to disable the switch submit button. As you can see here, ATTR is attribute. So we're going to disable it, and then on top of it, we're going to replace the HTML content of this object to be this HTML right here. And you can see it loads a spinner, and it has a loading ... So that's all it's doing. And let me just go up here, refresh, and you see, boom, it changed here. So you can see, what's checked. I changed some of the bullet point here for verify interface errors, the switch host name. You can see ASA is not on here, whereas over here it is. It's disabled, which is why it's highlighted in white. But over here, you can't choose ASA, and then the switch IP. And I'm not going to click submit button because there's nothing to submit yet. But all right. So we have the front end now. So the front end, we have the test script, we have the job file. Now we just have to glue it all together, right? And that's kind of where FastAPI comes in. And I'm using FastAPI. You can use Flask, Django, any kind of web framework, Python web framework. So in our case, like I said, to keep it simple for now, I'm just going to be copying and pasting all of this. Like I said, I haven't had time, and honestly, this is all on a whim. So I'm not exactly like, I'm sure I could review the code and we could condense certain pieces of the code. Like, since I'm basically copy and pasting this entire, all this code, like generating a test bed, getting the results, reading the device logs, like Obviously, like there's going to be a better way to do it. I just have to read into it a little more and figure out, what's most optimal, because this obviously isn't the most optimal way. But it's output driven. This stream is output driven. This application is output driven for now. We'll figure out refactoring and looking at it in the future. So, all right. So going back to the form itself, we posted. Remember, I said you have to remember that the name of that form, right? Not just for the JavaScript, but if you go back to main.py, we're going to say, okay, we're going to this route, validate switch install. We're going to use the response class HTML. What this allows us to do, it's based on actually, FastAPI is based on Starlet, and it allows you to return an HTML document, which you could have Jinja 2 markup and some other things. All right, so we're saying when we post or do a post to this URL, which in our case, remember, if you go up to the form, you can see with this form, when you click submit, the method equals post. And that's common with HTML forms. All right, so we post, we collect the request item object. It's just you have to collect it if you have any sort of parameters that you want to get from the form. So that's always first. So that's why you see request. And then these parameters, these names need to match. These parameters need to match what's on the form. And so I'm going to go through and just do a quick copy paste of switch host name. So we have switch host name, switch OS type, and switch IP. Right, so what this allows us to do is say, okay, we collected these 3 items from the form, and the way we did that was normally like it's easier to read with Flask in my opinion, because with Flask you can say, okay, get, you literally use a get method to say like form.get, and then you name the HTML object that you're trying to get, right? So it's a little easier that way, whereas this is being fed in as parameters. Kind of we just quickly go through this. So basically at this point we have the string values, or the values that were put in the form, and they're passed in as strings using our type hint here. That's how I know it's going to be passed in as a string. We're going to generate a test bed, and we're going to pass in those values that were collected from the form, switch host name, the OS type, and the IP, into the generate test bed method. You can see here host name, device IP, OS type. And pretty simple, generating a single test bed. Then we'll run the pyATS job. Now from the validation, I could revisit the validation, the helper method, but basically you can see here I need a job file name and then the current directory. So the current directory, that's not changing, but the job file name is. So instead of using circuit underscore job file, we're using switch. Actually, I'm going to call it switch underscore install. Let's change it up. Job file. And then from here, let's see what else. Job results. We're not, same variable. We're passing into here. Results dictionary, we're passing into here. Device logs, we're good. And then we're saving the results. Nice part about this is that all of the results, because we're using the Easypy execution, the results.json file, the values that we're trying to gather from it, and let me just go down to what we're gathering again. just so you have a better understanding. What we're gathering here, because we're not digging into each individual step, the format or the schema of that JSON file is the same, right? We're not going into a specific test itself. We're just sticking at the high level report. So it's super. That's kind of, and this is the nice part. And like now that we're doing like a second test, the only thing I've had to change is the parameter names and some of the inputs to generate the test bed. But because we have all of this built out to be very dynamic, that it can handle pretty much any data that's going into it. And since we're reading and getting the same results, it's pretty neat in that way. Let's see. We're reading the device logs. That should stay the same. And then, okay, here we go. Device IP. Oh, okay. So we actually need to return the switch IP. And I think if I remember right, this is being returned due to the name of the log file when you download the log file. So, okay. I think we did it. Let's check it out. Let me quickly, I forgot to set the, and they're not secret, so I'm not too worried about showing on stream. The environmental variables, because remember our test bed uses environmental variables, hence the markup here. Eve underscore user, Eve underscore PW for the username password. And I know we have SSH because, and I'll just go in here again. Oh. Enable. All right, so I can SSH from my laptop, well, desktop. So I know I can get in. All right, let's see. I'm just gonna do a fresh bring up of the application, and we're gonna test it out. All right, so the switch host name is called what? Stream dash SW. It is an iOS image. And I know I just quickly went through that, but iOS XE or iOS. The switch IP address is this, and we're gonna press submit. And you'll see that's the JavaScript that just kicked in, the spinner, and see how I can't click it. So it's going through. Let's see what it looks like on the back end here. The Easypy job is kicked off. You can see that here. All right, so we SSH to. So I don't see the username. Yeah, I didn't see the username or password there. I wonder if because it shouldn't matter though. Oh wait. Oh, that was the disconnect. I was like, it passed some things. All right. Let's just do env grep Eve. Okay. So let's try this again. For some reason, I guess because I set the environmental variables in a different terminal. Now I'm using WSL, by the way. This is all through WSL. Maybe because I didn't bring in a new terminal. Let's try it again. All right. Applications back up. Hey, look. This is a good example though, right? So I laughed because the only pass was the disconnect at the very end, but you can see it parsed the results.json file perfect. I don't know why those didn't show. Oh, because they showed up as errors, not failures. That's just something cosmetic. We can easily parse out that particular value. But hey, all the values worked. And then the device logs you can see here. Interesting. Actually, wait, it may have worked. Let's see. Oh wait, no, that's router 1. Oh, you know what? I bet that was some stale files. Because from the last stream, I didn't. Yeah, hold on. Because if you remember the last stream, we were reviewing what those temporary files were. Whereas now, so it used the old testbed, I think. Or I'm sorry, it used the old results JSON file, because at the very end here, it's supposed to clean up the file. Actually, I'm going to keep that disabled because I want to see what if this doesn't work, then I want to see kind of what the different parsed outputs look like. So, all right. Let's see. All right, so we refreshed. Let's plug in the host name here. Stream switch. iOS device 192.168.7.151. Submit. All right, so the form's in. I don't see the post yet, but there we go. Starting the job. So it says switch install job file. So it is running the right job file. Yeah, here we go. Sweet. Hey man, all it was the environmental variables. I just didn't have those set, which I knew I didn't before the stream. So, but let's see. I don't want to jinx it. I'll let it finish before I keep going. Boom. Done. And we check the temporary testbed form it created. There it is, stream switch, the IP, and what else was the OS. You can see iOS was put in there. Boom. All right, and then besides the testbed, the temp results. There we go. It formats to the host name of the device, the method used to connect to it. So we're just using CLI, and then a timestamp. And this is all just the raw. You can see it's been up for about 2 hours. Here's executing show process of CPU. Okay, so I said show platform CPU. Show process of CPU is what that API runs. You can see it's actually kind of running hot. And it's probably because I have a few different virtualized network devices running, but yeah, it's kind of running a little hot, 55%. Still less than 75% though. So you see show processes memory. So that's for the platform memory API, the device API for the memory. Run show version. So make sure that 15.2 is there. That actually may fail. I got to see what it gets parsed out. I don't, because it may actually pull some of this as well, but we'll see. And then show interfaces. So here's the show interface I was talking about. So you see gigabit 00, 01, 02, 03. So it only, luckily this virtual switch only has 8 interfaces, because look at all this data that we captured. And then finally it captures the log. So you can see it's just mostly links going up and down. Sweet. And then the results.json here, which if I just format it, you can see, let's go to the top. Yeah, you can see the values that we pull. Runtime, we still have to add that to the database. That's on our to-do list. But you see where the job file that was ran, switch install _ job file, and then the summary. So it did pass. So it must have got the right image, the 15.2. So yeah, 3 tests were ran, 3 passed, success rate 100%. And so now, since we have the device logs, we see the results.json printed out properly, we now should go to this page, and sure enough, 100% success rate, 3 tests ran, 3 passed, and here's all that data we just went through. That's pretty awesome. That's pretty sweet. So, yep. And if you do it, and if you click download, perfect. So you get the timestamp, and yeah, so that's what the IP address is for. You get the timestamp of when the test was ran, the IP address of the device, and then just -results.txt. And so if you download that, you essentially get that. We just had it up. You get this log file that I just showed you. Pretty sweet stuff, if you ask me. Because I did not plan. I didn't do any of this before the stream. I was planning just to do this. Like I said, this is one of those things that this time it worked out great. You know, the demo gods looked upon me. So yeah, I think we got it done. So there's, like I said, there's probably a better way of doing this method here. And if we want to go kind of that async route I was talking about, where the job runs in the background and then all the results are posted on a separate page, then we got to change some things up. But I mean, hey, it works. We got the results we're looking for. And yeah, the easy part now is now we just have to create some additional tests for the default gateway, make sure default gateway is set, spanning trees configured, and then VTP is disabled. But once we have those tests, and I mean, we ran through this one, which was pretty simple. These ones I think will even be simpler. As long as there's like an available API or parser, then we're set. We'll be good. And then you have, just simple as that, we have another test for, just open this up. We just have another test to add to our toolkit. You know, we can test for circuit upgrade, and we test for a fresh switch install. So cool. Well, I appreciate everyone that tuned in. I know the start of this stream was a bit rough. The audio is all messed up, and OBS couldn't recognize any of my audio capture devices, so that was that sucked. But I appreciate, you know, those that were able to join. And if you're watching this on YouTube, thanks for sticking around. You know, this was really from 0 to 100, creating a pyATS test script that included steps and a individual test case, how to run that test script using Easypy, and then how to connect it all up with a web front end using FastAPI as the back end. So I really hope you guys enjoyed it. There's a good chance that, you know, if I get some feedback with this, that I'll make a much shorter YouTube video, because I know, let me see, we're on almost 2 hours, hour 48 minutes. That obviously not everyone's going to watch almost 2 hours of a live stream, at least on demand. So I may make this into a smaller video and post it on YouTube as well. So, well, thanks again for everyone tuning in. Oh, shoot, I forgot. I meant to do this at the very beginning of the stream, but I have a new widget. Let me just play the music. So I think I played some music last time as well, using the no copyright sounds playlist on Spotify. So that playlist is pretty awesome. They have a YouTube channel as well, which is where I actually got my my intro and outro song from. They have a couple of different playlists on Spotify. So the music that you're hearing in the background now, which I was planning to have all throughout the stream, that is from the No Copyright Sounds Spotify playlist. And if you notice in the bottom left corner, that little overlay will actually tell you the name of the song and the artist. So as we, are going through coding or any time during the stream, if you like the song, you can get the information from the bottom left of the screen. So maybe next time, because I obviously forgot this time with all the different issues I ran into. So thanks again for everyone tuning in. And this Thursday, on the 28th, I'll be doing probably the last, but part 3 co-stream with John Capobianco again. Obviously, if you watched the last one, part 2, we ran into other technical difficulties. So this time, though, we'll have a sandbox environment, and we should be able to actually finish what we started. So that will be this Thursday. So we'll pick up again with NetCheck next Tuesday. So that's it for me. I appreciate you guys watching, and I hope to see you in the next stream. Talk to everyone later. See you.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on